Hello! Today we're gonna go through a problem that teaches us how to find the center of mass of irregularly shaped object. Let's read the question together. Find the center of mass of the object shown in the figure. Object comprises three metal cylinders welded together. The length and the cross-sectional areas of the cylinders are 4D and S, D and 4S, 2D over 3 and 6S. So before we start, let's identify certain symmetries in this object. So, as you can spot, this figure or this object is symmetrical around this central axis, right? Because all these cylinders share same central axis. So we know for a fact that center of mass of this object is going to be along this line. Now, what about this lateral position? How are we going to calculate this? Well, let's first identify what those lateral positions are. So let's set this point to be 0. The center of this cylinder is 2D. And we all know that center of cylinder or rod is going to be right at its middle, right? Middle point. So it's 2D is the center of the mass of this cylinder 1. Center of the mass of cylinder 2 is going to be right in the middle of the cylinder 2, right? So if this distance is 4D and distance is going to be D over 2, so this distance from the starting point is going to be 9D over 2. Likewise, to calculate this distance, we take that this is 5D and we add to it 1D over 3 because it's right in the middle, right? So 5D plus D over 3 is going to give us 16D over 3. So let's recall the formulas for the center of mass of a collection of objects whose masses are given and whose coordinates are given. The formula to calculate center of mass is shown here. So you just have to multiply the mass of the object with its corresponding x, y, or z coordinates and sum them up and divide by the total mass. Well, that's exactly what we're going to do. So we're going to write down the masses of these cylinders multiplied with their corresponding x coordinates, because we don't have to worry about y and z because we already identified it to be along the central axis. So center of mass along this x-axis is going to be m1 times x1 plus m2 times x2 plus m3 times x3 divided by m1 plus m2 plus m3, right? So 1 stands for the first cylinder, 2 stands for the second cylinder, and 3 stands for the third cylinder. So what is the mass of an object? It's density times the volume. So these are all same cylinder. These cylinders are made out of the same metal. So their density times the volume. Volume is just a cross-sectional area times the length. So this is a mass of the cylinder of 1, right? And the position of this is going to be, of the center of mass, is going to be at 2D. So mass of the cylinder 1, mass of the cylinder 2, mass of the cylinder 3 times their corresponding positions along the x-axis and divided by, again, the sum of their masses. Now, the common terms here are rho. All of them have rho. All of them have s. All of them have d and times d, so d squared. We can take it outside of the bracket. At the bottom, we have rho, s, and d. So if we do this, we are left with 8 plus 18 to plus 64 over 3, and then inside at the bottom we have inside the bracket 4 plus 4 plus 4. Row, area, and d cancels out and leaves 1d here, so you end up with 71d over 18, which works out to be 3.94 t. So what is the center of mass of this object then? Well, it's right before the point where the first cylinder ends. So from here to here is 4d. So center of mass is going to be somewhere here, right before point K. So it's going to be between O1 and K. It's very close to the point K, right? So this is the answer for this problem. And I hope this is clear to everyone. Thank you.